why the importance of the special right triangles are there, why everything, why there's certain relationships that happen within the triangles and the numbers and all that kind of stuff. And this first section of basically the non-calculator part of this unit is kind of going to help us with everything else. So I would definitely anticipate us making sure that we are really good at this stuff before we move any further. So don't be surprised if we do this for the next, well, tomorrow's a half day, for the next 2.5 days. And that's fine. There's no worries about that at all, because I always found that this, I always found that this unit is really, it's one of the ones, if we get it right, everything else falls into play. So what I like to do here is, first of all, after I get this piece of junk out of my eye, all right, is to remind you guys of your coordinates, or your quadrants, excuse me. A lot of this stuff is going to start talking more and more about quadrants and where certain values lie as far as angle measurements and stuff are concerned. So remember how the quadrants are labeled. So it's quadrant 1, 2, 3, and 4. One of the rare occasions that we still use Roman numerals. Watches, oh, this one doesn't matter. You have those. The coordinates for x and y here, they're both positive. Negative, positive. Negative, negative. And positive, negative. We okay with that? We think we remember all that, right? Zero, 90, 180, 270, and 360. We okay with that? Yes, no, maybe so. Now, what we do here is we start talking about what are called angles in standard position. Angles in standard position, when we draw them, they're going to always start at the same spot and rotate around. For example, can I have a clean one? Give me a second here. I will have a sip of coffee and then I will go. It's like we were twinning.
That was weird, yeah.
That was pretty cool. Air 5 for hydration. You get what are called angles, or angles, and what are called standard position. Angles in standard position, remember every angle has two sides to it, and those sides were always called rays. The vertex of the angles where the two rays intersected, and the rays, the degree measure of how far apart those were, was how you figure out your angle measurements. So what we do is we always place angles with their vertex at the origin of the coordinate grid, if you will. Your terminal side, or I'm sorry, your initial side where the angle starts is always placed at 0. And then it just opens, however many degrees up. So I would say that this might be 70 degrees. That's how I would draw an angle in standard position. Positive angles always go counterclockwise. Okay? Negative angles, yes, there can be a negative angle because it's just a direction. Go clockwise. All right? You have positive angles, I'll write it out here. Positive angles. I've told you guys this before, that my angle symbol is weird looking because I don't know, that's how I was taught, and it's just what I do. Positive angles are drawn counter clockwise, that direction. Negative angles go clockwise. The positive, negative, it just means direction. Okay, you're just moving a different direction. You'll get more involved with directions in what are called vectors in pre-calc. It's so hard for me not to say vector. Roger. So what we do here is we're able to draw angles into standard position by basically just counting degrees. And you're going to do some rough sketching. The idea here is that you guys will always know where your 90 degrees are, 180, 270, 360, because those are all the right angles. Then it's just a matter of guesstimating, here's about halfway, so that would be like 135. Here's another halfway. You start to play around with where things can fly into. Now, if you draw something and you're completely in the wrong quadrant, bad things, but if you're okay, it's fine. Let me show you an example. I want to draw 210 degrees in standard position. I'm going to draw 210 degrees in standard position. Well, first thing I need to do is create a grid. $210. Start at 0. Am I going to go clockwise or counterclockwise? Counter. Here's 90, 180. How many degrees off of 180 is 210? 30 degrees. There's my 210. Quadrant 3. What I'd like you guys to do, and I'm going to do this a little different than I have in the past. I'd like you guys to always figure out how far you are away from the x-axis whenever you place something. Okay? Whenever you place an angle, when you draw an angle, I want you guys to always ask yourself, how far away are you from the x-axis? In this case, this real quick. Easier to see. In this example, how far away are you from the x-axis? 30 degrees. So you have to come back up 30 degrees. There's a reason why I'm doing that, and you'll see why maybe Friday, probably more than likely on Monday, when we start talking about what are called reference angles. They're kind of important. What's 30 degrees? What's the sine of 30? Exactly. Okay. So we did 210. Let's do negative 45 and 510. The look of, huh? We're going to do some spinning. 3 rights. You're going to like this because you get to turn around in circles a lot.
I'm not good at that.
You'll get better.
I get confused.
But you're right from your left, so that's a plus.
Yeah, when I use my hands.
It's okay. It's okay. What quadrant does negative 45 land into? 4. How far away is negative 45 degrees from the x-axis? It's 45 degrees away from it. It's quadrant 4. You guys know what Roman numerals are, right?
Yeah.
You've seen Rocky 1 through 7. Is there 7 Rockies? There's 6.
There's too many. Unless you count 3.
What?
Like Roman numerals.
Oh, okay. You say you learned about Rocky from a history class. Like, what? I'm really that old? Mm-hmm. I just started thinking of that too. 510. That's weird. Is 510 past one revolution? Yeah. How many degrees is one time around? 360. So what happens is you're going to spin around until you get to 510. So you have to start thinking to yourself, okay, if I go around 360 degrees, how much further do I have to get to 510? That's 150, isn't it? Now, if I, at 360, I'm basically starting over at 0, so I have to go back to 150 degrees, so I go past 90, and now how far off would I be from 180 degrees then? I'd be off 30 degrees here, and here's my 510. But yet, what quadrant did that put me into? 2. Now, one thing I want you guys to see is that after we got out of one revolution, we basically subtracted 360, and we had to figure out what was left, correct? And we got, what was it, 150? Now, if I drew just 150 degrees, it would be right here, and those two guys would be in the same spot. They share the same, what's called terminal side. Remember, where an angle stops, this is called the terminal side of an angle. It's where it ends. Angles always start at the initial part at 0. They terminate, they terminate on the, yeah, that was bad. You shook your head, yeah, I know, I tried. They finish at a certain angle, or at a certain position, so that's what they call the terminal side. So anytime an angle, if two angles share the same terminal side, terminal, is that right? Yeah. They're called, it's a real difficult term, coterminal. Coterminal angles just share the same side, the same spot on when you spin them around. Okay. You see this a lot. We actually use it a lot to help figure out what are called reference angles. And if I go into something that's really, really simple here, we'll just replace this one. That was 510. If I think about this idea of coterminal, and I do something where it's really easy. If I say that's 45 degrees, every time I spin around my axis here, and I land on that, it would be coterminal. That makes sense? So the first coterminal, if I add to that, what do I add to wind up to 45 again? 360. So what's 360 plus 45? It'd be 405. So 405, if I do that again, I'm adding another 360 to that. So I could be at 770, excuse me. Oh no, 765. For some reason I was thinking 365 because of the days in the year. Okay? So each time you spin around, you wind up on the same spot. Well, it works going the other direction as well. You can have negative coterminal angles because a negative is just, it's not negative in the sense of like you've like negative $7 or you're down $7 or whatever. It's just a different direction. So if I spin the other direction, move these out of the way. If I go the other way, what would that angle be? negative 315. Because I'm going the other direction, since this is 45 degrees off of the axis, where it would be one full revolution, you're subtracting it up. So you can get what are called positive and negative coterminal angles. All that is just that you're finding them within the revolution of going past it or unwinding it. Okay? Now, there's a couple little rules here and there about working with coterminal angles. And I'll show you that. I'm going to do one more example with a normal number first. Let's see. Which one did I have? Okay. Let's do it with negative. Let's find a positive and a negative coterminal angle for negative 60. Negative 60 would be placed in the fourth quadrant. It would be right there. Negative 60 is 60 degrees off of the x-axis. Okay, so we'd have to take 60 degrees to get back up, so it's 60 degrees off. Now, if I'm going negative, I'm just going to continue on and all the way around again, which means what angle would that be at? If I'm going to go another negative coterminal angle, it means I have to start here, go all the way around, end up there again. So if you go all the way around something, you're going how many degrees? 360. So if I start it here, I go all the way around 360, how many more do I have to go? 60. So that would be at negative 420 degrees. If I went the other direction to get to that position in that fourth quadrant, if I started at 0 and I went positive, how many degrees does it take me to get there? 300, because that 60-degree angle is how far off of 360. That's what you were working on. We're working with how far you are off of one of the x-axes. Because you can easily add and subtract that value, whether you're coming off of 180 on one side or 360 degrees off the other. That's how you are able to figure out your position, your angle measurements. So the other one, the positive, would be at 300 degrees. So when it asks you to find a positive or a negative, or positive and a negative coterminal angle, if your initial angle is within one revolution, positive or negative, which means it's between 0 and 360 plus or minus, all you have to do is add 360 or subtract 360 and you'll get your two angles. On the other hand, if it's above one revolution positive or below one revolution negative, you have to back it up once or twice to get you there. It's a little weird when you're talking about that. Let me show you. 495. 495 is beyond 360 degrees. Are we okay with that? 495 would start you at 0. You'd spin all the way around 360, and then you'd have how many degrees left to get to 495? Well, here's 360, and then I'd have to go to get to 495. I've got another 135 to go, correct? 135 degrees to go would be halfway into quadrant 2, wouldn't it? It'd be halfway into quadrant 2. Now, how far is that off of the x-axis then? If you're up in the second quadrant, you're how far from the x-axis? You're 45 degrees off. Okay. So this angle is at 495, but I had to go all the way around once. So whenever you have something that is beyond 360, in this case positive, what I want you to do is to find the first coterminal angle positive. All you do is subtract 360. To get the negative coterminal angle, subtract 360 again. Because if you go the other direction, here's negative 180, and then you're going another 45 degrees up, you're at negative 205. No, 225, excuse me. And the reason that I can do that quickly is because I'm figuring out how far it was already past the x-axis. And as long as we know that this is at 180 on this side, and this is 0, and that's 360, by understanding how far you come up or down off of the x-axis, it's really quick to know how much more you have to add for something as you're spinning things around. It's a weird concept to get the hang of, but none of you guys are really looking at me with completely blind stares. So it might not be as bad-ish. Those are heavy. Let's try another one. No.
Do we make this more complicated tonight?
Yeah. It's exciting. It's so exciting. I should show you guys something really fun. Let's do a positive and a negative coterminal angle of negative 320. We do a positive and a negative coterminal angle of negative 320. So the first thing I'm going to do is draw where negative 320 winds up. Well, the negative angle just means it's going clockwise. So I start at my 0, and I know if I go all the way around, I'm going to be back in quadrant 1 with how many degrees to go off the axis? 40, good. So I have my negative 320 degree. It's 40 degrees off the x-axis, which means, was I within one revolution or was I beyond one revolution? We were within. Since the negative 320 is within one revolution, all I have to do is subtract 360 and add 360 to get my two different angles, my positive and negative coterminal angle. So to do the negative, you're basically starting back at 0, going negative 360, going another negative 320, and you wind up at negative 680 for the negative coterminal. You spin around twice-ish. To do the positive one, well, I knew that my negative 320 was only 40 degrees off the x-axis, so if I just add it, I get 40. It's a nice little shortcut for some of these things. Look how far off you're going to bounce from the x-axis. Never worry, ever, actually don't even worry. Never, ever, ever, never, 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 ever, never, 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 ever, ever, never, 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 ever, ever, never, ever. So solemnly swear, ever measure off a y-axis. Only x-axis. Deal? Thank you. Which means I get to show you something even more fun. We got 20 minutes. Radian measure. Ah, radians. It's what the real world uses. We don't use degrees. You know how English people, well, English, I mean, as Americans, we generally use the feet and inches and stuff like that, but scientists use metric system. It's kind of the same idea with degree measure and radian measure. Radian measure is a more standardized thing. It's not as evident, or it's not as widely cut and blank. I mean, a lot of us still use radian measure in the United States, but it's it's one of those types of things. You're either going to use degrees or radians. Degrees, we're fine, nothing wrong with it. Most of you guys all know how to draw where 180 degrees is. It's over here. You know that 135 is here and stuff like that. But if I say 3 pi over 2, you're going to go, what? So the idea here is that we introduce you guys to what radian measure is, because that's what everything else is. And that's how you're able to do all this trig stuff. How I said that we'll be able to do everything without a calculator. Because if you understand radians, you know what all the degree measures are. And then if you understand radians, you understand degrees, all you need to know is how do you work with 2 triangles, the special right triangles. Everything that you've ever learned about them is because we prepare you for this unit. Yay! So, back to our grid. If you start at 0, 90, 180, 270, and 360. When we talk about in terms of radians, this is where pi comes in. Think about circumference, 2 pi r. It takes 2 pi to get around something. We're going to turn this into a circle because you can draw degree measures out of it. So if you start at 0, 0 times pi would be 0. If I come all the way over to 180, halfway around a circle, well, if going all the way around a circle is 2 pi, halfway would be pi. What would half of pi be? Well, what's half of 180? 90. What's half of pi then? Pi over 2. It's magic. So if I'm going from 0 to 90 degrees, I'm adding a pi over 2. This becomes 2 pi over 2, simplified fraction. This would be 3 pi over 2, because back at 360, you're at 4 pi over 2. You're counting by halves. 0, 1 half, 2 halves, 3 halves, 4 halves. As you're going around, you're just using fractions with common denominator. So you get 3 pi over 2. Okay? Now there's a conversion for this, but I'd rather not show you that right away, because it's more fun this way. What's half of 90? 45. So I take 45 degrees. What's half of a half? A fourth. So what's half of pi over 4, pi over 2? Be pi over 4. So at 45 degrees, it would be pi over 4. Because halfway between 1 half and 0 is a fourth. What's half of a half? You can come in. Now watch this. 1/4, 2/4, we're at pi over 2. 3/4, 4/4, 5/4, 6/4. Catherine, don't look so sad. 7/4, and then back to 8/4. It's just breaking it into smaller chunks. 45, 90. What's 90 plus 45? 135. 1/4, 2/4, 3/4. 4/4 is 1. This would be 5/4. What's 180 plus 45? Write that down. Okay. Notice, this is a little trick to show you here that you'll catch on hopefully. How far apart are those 2 degrees? They're 180 degrees apart, aren't they? Which means these two are also going to be 180 degrees apart, right? crazy how this works. It's really nuts how this stuff all comes together.
This doesn't.
So 270 plus 45 degrees is your, was it 315? Okay, track.
I don't get like what the pi is, just like.
When you did circumference of a circle, circumference of a circle was 2 pi r. We're saying that our value of r can be anything. It's always going to simplify out to have 2 pi to get all the way around it. Every circle has a circumference of 2 pi times some radius. It doesn't matter what my radius is for any of this, I'm just going around a circle. That's where it comes from. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, this is 7/4. Okay? So, what are the other two special angles that you're missing? We have 45s and the 60. If I draw in my 30, what's the relationship between 90 degrees and 30 degrees? It's a third of it, isn't it? What is 1/3 of 1/2? 1/6. You're just rolling your eyes going, oh crap, I didn't sign up for this.
I didn't mark this graphic.
I get pi over 6. Now watch what happens. 30 degrees, if I go 30 degrees, the next one would be 60 degrees, 90 degrees, 120, 150, 180, 210, 240, 270, 300, 330, 360. Every other one of these angles can be moved by this 30-degree mark. Everybody okay with that? Because 30 degrees, if I double it, I'm at 60. I triple it at 90, and so on and so on. So if I walk around, I get a 60, we have the 90, 120, 150, 180, 210, 240, 270, 300, 330. Which means for every one of those 30-degree angles that I move up, I'm moving up 1/6 of the circle. So if you count through it, without putting pi in it for right now, 30 degrees you're at 1/6, 60 degrees you'll be at 2/6, 90 you're at 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, and all those fractions simplify out. So technically, you can do all of this building out every one of these degree measures just by knowing simple fractions. Okay? So this is 1/6. This was 2/6, but we write it as 1/3, so it's pi over 3. 1/6, 2/6, 3/6, 4/6, which is 2 pi over 3. 1, 2, 3, 4, 6, 5/6. This would be 5 pi over 6. 6/6, 7/6, 8/6, which is 4 pi over 3. 9/6, 10/6, which is 5 pi over 3. And this is 11 pi over 6. That's the unit circle. What's that?
I didn't write all that
You're going to want to make sure you know how to build that. This little bit of fun is going to allow us to then get all of the different ordered pairs that are created for all the cosine and sine values of each and every one of those angles going around the unit circle. But in all honesty, all you have to do is know 3. If you know what the sine of 30 is, the sine of 45, the sine of 60, and the corresponding cosines, everything else is replicated because of rules of horizontal and vertical lines. And this takes us quite a bit of time to develop and show, but the basic idea is, can you convert something from a degree measure to a radian measure and spin it? Okay. So conversion-wise, this was just a quick working with angles that make sense. But if we want to convert degrees to radians, all you do is you take your degree, slap a pi next to it, divide it by 180. Simplify it. So if I wanted to convert that 110 degrees into the radian measure, if I want to take that 110, slap a pi next to it, throw it over 180, and try to simplify. What can you simplify? Which what? The zeros. You get 11 pi over 18. Okay. If I have going the other direction, negative pi over 9, I want to go to degrees. Well, all you do is the inverse. You take the radian and you multiply it by 180 over pi. Because you want the pi's to drop out. Pi's will always be thrown in numerators. So if you're going to go to degree, just know that you have to divide by the pi to get rid of it. So the pi's drop, and you get 180 over 9, negative 180 over 9, which is how much? Negative 20. It's exciting. What if I ask you to place a radian measure into a degree, or not a degree, yeah, place it into standard position? Should we try that today or wait for that tomorrow? Might not be a bad idea because that gets a little messy. Well, I'm not really worried, but it's a lot today. That's a lot. Okay, there's a lot going on here. Yeah, because this can get overwhelming because there's so many things that you can do with each one of these steps. So let's do this. We did drawing angles in the standard. We haven't done coterminal with radians yet, so we haven't been. To do coterminal with radians, instead of adding and subtracting 360, what would you be adding and subtracting? What's the radian equivalent of 360? 2 pi. So to convert, to go with, to do coterminal angles of radians, you will add or subtract 2 pi. I'll give you a couple, let's see if you can do it. We'll probably start with that tomorrow. So let's do this. So this is 13.2, page 780. Okay. I gave you a couple of find the coterminal angle of 24 pi over 7. And I'll show you how that will work real quick here after I write those down. The 36 through 59, the majority of that chunk of numbers is just converting between radians to degrees or degrees to radians. So it seems like it's a lot there, but it's just it's a lot of one step simplifier fraction type thing. if I want to do coterminal of 24 pi over 7, first thing, this is, you know how I told you guys how much I loathe mixed numbers? This is the one time which mixed numbers make sense. Do you remember how to convert a top-heavy fraction into a mixed number? Well, think of it this way. 7 goes into 24 how many times? 3 times, and how many are left over? 3. So this is 3 and 3 pi over 7ths. Or 3 and, sorry, let me rephrase that. This is 3 and 3/7 pi. Are you okay with that? Is that beyond 1 revolution? Yeah. So here's what happens. If I want to draw that, I know that this is 1 pi, 2 pi, 3 pi. And then I ask 3/7. Is 3/7 more or less than a half? It's less. 3/7 is less than a half, so this would be my half pi area, so it's going to have to come down here. It'd be there. Now, knowing by counting back and forth, we went 1, 2, 3. How far did I go off of that x-axis? 3/7. I went off the axis 3/7 pi. So that means that since I've already gone around 1 full time, I need to subtract 2 pi. If I take 3 and 3/7 and I subtract 2, what do you get? 1 and 3/7. So your first coterminal is 1 and 3/7 pi. To get the negative, I subtract 2 again. What's 1 minus 2? Yeah, that's not, wait, I could do from negative. Yeah, because if I do -2, then I'm at 1. Yeah, -4/7, yeah, duh. Which makes sense because you're coming over, that would be up here. No, what did I mess up there? It says 1. Because if I come around, here's 1 pi, 3/7, that's 1 and 3/7. Here it's 3/7. It'd be 1 pi minus 3/7. So, okay. So obviously you have to come back. If I come up to 1 pi, that's 7 pi over 7. Are we okay with that? 1 pi, if I'm going the other direction, would be -7 over 7. But to wind up here, I had to move backwards how much? 3/7. So I turn this into, it's a little weirder when you're dealing with the radian. It's a little bit weirder because you want to always make sure you're the same value off the x-axis. It'll be a little weird. That'll take a little bit more practice on it, but this just give you ideas so you can try them out. Okay? If this was a lot to start with, that's okay. If you're a little overwhelmed, it's okay. It'll take a couple of days to get through this and actually practice a lot of it. And believe me, I have no doubt you guys will be flying through this stuff probably by the end of the day tomorrow. If not right away, it'll be like this halfway into Friday. So don't freak. Okay? It's okay. All is well. Radians are radical. We can show the movie Radigan if you want. Oh, I know. Isn't it hysterical?
I sent her my notes, but my notes are just like graphs. I don't think it's gonna make sense. She's gonna be like, what?